Well, hi there sports fans, and welcome to another exciting edition of Physics 12. Today we're looking at lesson 1.7, which is again on vector notation, but we first looked at vectors in polar form. Today we're going to be looking at rectangular form, but let's just review polar form as we talked about the other day. First of all, vectors in polar form, they are expressed with their magnitude and direction. In other words, their angle, using north, south, east, and west. And so here's an example of a vector. We have north, south, east, and west indicated on our grid here. And our vector is going down in this direction. We have a velocity vector. And so let's look at how we would express this in polar form. First of all, its magnitude is 6.2 meters per second. And we measured the angle to be 32.7 degrees. And so we would express this angle in polar form as such. So this velocity vector is 6.2 meters per second at 32.7 degrees west of south. Okay, so this angle here, that being west of south. Now, you could also write it this way here as well. If this angle is 32.7 degrees, that means that this angle has to be 57.3 degrees. And so it would be equally as correct to say that this vector, this velocity vector, you could also express it as 6.2 meters per second, 57.3 degrees south of west. And that would also be indeed correct. So these two vectors are identical. We're just using different reference angles in order to describe their direction, but either one is correct. So here's polar form. Here's polar form. Now let's look at what we call rectangular form. How does rectangular form compare with polar form? So here we have another example of a vector right here. We'll call it vector A. And in rectangular form, first of all, its magnitude is 13 meters. Its magnitude is 13 meters, so it's a displacement vector now. And the angle we measured to be 22.6 degrees. All right, so in rectangular form, all we're actually doing is we're expressing the x and y components of the vector. So all we're really doing is we're finding what's the x component of the vector, what's the y component of the vector, and that's how we express it in rectangular form. So this vector being 13 meters in magnitude, its x component would be 13 cos 22.6 degrees. And that's just your basic trait. So the x component here, 13 cos 22.6 degrees. The y component over here, you would determine that by being 13 sine 22.6 degrees. So your angle is 22.6, the x component 13 cos 22.6, the y component 13 sine 22.6. And that would be the x and y components of this vector. And that indeed would give us the, if you do the calculations, then you get the x component is 12 meters and the y component is 5 meters. So therefore, in rectangular form, this particular displacement vector would be indicated as vector A is 12 meters in the I direction or the x direction and 5 meters in the j direction or y direction. So this right here is rectangular form of a vector. Now this is quite useful actually for when you're adding vectors together. Because anytime that you add vectors together, you're actually adding the components together. So if your vectors are in polar form, really what you're doing is you're changing to rectangular form in order to find your x and y components, and then you add them together that way. But if they're already in rectangular form, it makes it a whole lot simpler. So let's say we have displacement vector A and displacement vector B. And both of these now are in rectangular form. And so let's say we wanted to add the two vectors together. So vector C is vector A plus vector b. And if they're already in polar form, then all we have to do is add the x components together and add the y components together, and then you're done actually. So the x components would be 12 plus 4 right here, and the y components, or j direction, would be 5 plus 7, which is right there. And that then works out to 16 meters I plus 12 meters j. So vector A plus vector B is vector C, which is 16 meters I plus 12 meters j. So you can see it becomes a pretty simple exercise to add vectors together when you have them in rectangular form. So here's our resultant vector when we've added them together. Here's vector C, which is vector A plus vector B, and the component in the x direction was 16 meters, and the component in the y direction was 12 meters. So here is our resultant vector C, which is vector A plus vector B. So there it is in rectangular form. Now let's say we wanted to change it back to polar form. Then what we could do is we could just find the hypotenuse right here. So we can find this length. If this length is 16 and that length is 12, then this length will be the square root of 16 squared plus 12 squared, and that gives us 20. And then we can find the angle using the inverse tangent of 12 divided by 16. Again, that's just basic trigonometry, and then you'll get an angle of 36.9 degrees. So there it is. There's your vector in a rectangular form, and then we go down and we change it to polar form, and it becomes 20 meters at 36.9 degrees, and this now would be north of east, this particular vector C. So that's rectangular form and polar form. You need to be able you need to know both, and you need to be able to go back and forth between the two.